Welcome to the Deep Dive. We take complex topics, break them down, and give you the essential insights. Today, we're zeroing in on a big challenge in fabrication, bending materials accurately. Think aerospace parts, structural bits, getting those bends just right repeatably. That's tough. We've got the specs, the feature list, all the details on one machine aiming to solve this. The Ercolina TB100 Top Bender. Our mission: to figure out what makes this thing more than just a bender, why it's a potential game changer in precision manufacturing.
Yeah, and what's really striking, I think, is not just the power, which is considerable, but how it marries that power with almost surgical precision. It takes bending from, maybe more of an art form into a real repeatable science.
Okay, let's get into it. Fabricators often struggle with different material sizes, different types, sometimes needing multiple machines. What are the core capabilities here? What lets the TB100 handle such tricky stuff so easily?
Well, the raw capacity is pretty formidable. We're talking bending up to 4-inch tubing and 3-inch Schedule 40 pipe now. If you know pipe, that's thick, rigid stuff. Even 3.5-inch square tube. But it's not just size, it's the versatility too. Large pipes, tubes, squares, rectangular profiles, even solid materials. That kind of breadth means shops aren't as limited. It can open doors to new kinds of projects, maybe reduce the number of machines they need.
4-inch tubing. Wow, that's definitely serious scale. Opens up possibilities for much heavier work. Okay, handling materials that heavy, that usually lead to inconsistencies. How does the TB100 keep things accurate, bend after bend, especially for demanding jobs? This must be where the smart part comes in, right?
Exactly. The brain here is its TC Plus control system. It's pretty intuitive. Forget clunky old interfaces. Picture a 7-inch color touchscreen. Simple icons. Makes it easier for operators, less training time, fewer errors, regardless of language even. It supports multiple languages. And it's flexible. You can store, 30 bends in one program? And unlimited programs via USB stick. But the key thing is fine-tuning everything. The bend speed, the angle, and crucially compensating for material springback on each bend.
Springback compensation. Anyone who's worked with metal bending knows that term. That's a big headache usually. Why is that specific feature such a game changer?
Oh, absolutely. Because materials, they always want to spring back a little after you bend them. It's just physics. Different materials, different amounts. Even slight variations in the same batch can cause problems. Traditionally, that meant trial and error. Lots of it. Wasted material, wasted time, especially with expensive alloys or when you need tight tolerances, like in aerospace. With the TB100 system, it calculates and applies that compensation automatically in real time. The idea is you hit your target angle the first time, every time. It's not just saving material, though that's huge. It speeds up production, less skilled labor time spent fiddling. Plus, it electronically monitors the counterbending die, so that theoretical precision, it actually happens in the real world reliably. Your 1,000th part looks like your first.
Okay, so it's smart, it's incredibly precise. Got it. But these machines live in tough environments, right? Workshops, heavy materials flying around. Is the TB100 built to last? Can it handle continuous heavy use?
That's definitely a critical point. And yes, it seems built for it. Heavy-duty steel gear case, for starters. But the really big engineering choice here, it's all electric. No hydraulic components.
No hydraulics at all.
None. Think about hydraulics, the potential for leaks, the fluid mess, contamination risk, performance changing with temperature. Going all electric just cuts out a whole layer of maintenance issues and potential downtime. It's cleaner, often more reliable, and actually electric drives can offer inherently finer control over the bend, which feeds back into that precision we talked about. Plus, likely better energy efficiency. Add in things like a quick change tooling system, foot pedal operation. It's clearly designed for uptime and productivity.
Right, that makes sense.
Okay.
Especially for high-volume shops where downtime is killer. Okay, so let's pull this all together. What's the real-world impact for industries, for the products we see every day? What problems does this machine fundamentally solve?
Well, connecting it to the bigger picture, it tackles those core manufacturing challenges. Consistency, getting things done efficiently, and keeping costs down. Think about sectors like automotive, aerospace, structural work. Precision and reliability there are non-negotiable. The TB100 delivers that consistent quality, whether it's, say, a complex exhaust for a performance car or critical pipe work in a processing plant. It ensures every bend is right for one-off prototypes or full production runs. So it's less a machine purchase, more like a strategic investment. It lets fabricators take on harder jobs, bid more competitively, and just, raise the quality of their work, turning raw stock into precisely crafted components faster and more reliably.
So there you have it, the Ercolina TB100 Top Bender. A really potent example of how smart engineering tackles long-standing fabrication hurdles, bringing serious precision and efficiency to bending.
And it makes you think, doesn't it? As machines like this get smarter, more integrated, offering this level of precise control, what does that open up? What new possibilities emerge in design, in how we use materials when you can shape them this accurately, this automatically? How might that change innovation in ways we maybe haven't even considered yet?